Hello and welcome to this video. In this one we're going to be looking at invalid proofs. So invalid proofs are any type of proof where you make some type of error. Could be at the start, could be at the beginning. If you make any error, it's going to make it invalid. So one error in reasoning results in an invalid conclusion. So every single step has to be correct, has to be valid. So a premise is going to be a statement assumed to be true. Often you're going to start off your proof with a premise. You're going to build off that, and then you're going to prove something. So if an assumption is not true, any argument built on that assumption is also not true. So you got to start with something true, and then everything after that has to be factual, can't have any errors. So in this first thing here, we got an argument 1 and argument 2, and there's some different premises for those. So in argument 1, it says everyone who drives at 90 kilometers an hour is breaking the law. Kai is driving at 90 kilometers an hour. Kai is breaking the law. And then argument 2 says everyone who drives at 90 kilometers an hour is breaking the law. So that's the same as this one. Then it says Rose is breaking the law, and also Rose is driving at 90 kilometers an hour. So I want you to read through those and kind of think for yourself whether any of those do not seem reasonable. So you want to ask yourself the question, do these seem reasonable? If they don't seem reasonable, then they're most likely invalid. Just kind of go with your gut feeling. So you can pause the video, read through those again if you need, and think about whether these seem reasonable or not. So myself reading through these, I would say this first one here, everyone who drives 90 kilometers an hour is breaking the law. I wouldn't say that's always true, right? You could be on the number 1 highway where you have a speed limit of 110 kilometers an hour. So if you're going 90, you're definitely not breaking the law. So I'm going to say that this is invalid. And then our reasoning behind that, not everyone who drives 90 kilometers an hour is breaking the law. Next, what we're going to get into is valid or invalid arguments. So we're going to have to look at these different arguments and then determine whether they are valid or invalid and then justify our response. So A says Val lives in Sylvan Lake. All people who live in Sylvan Lake like to swim. Therefore, Val likes to swim. So pause the video, read through that, and see if you find something that doesn't seem reasonable. If it all seems reasonable, then it would be valid. So reading through this again, the first thing it said was Val lives in Sylvan Lake. That seems reasonable, nothing wrong with that. All people who live in Sylvan Lake like to swim. Now this, I think, has an error, because when you say all people, imagine saying everyone in Sylvan Lake likes to swim. That is a very general, widespread statement. The chance that every single person likes to swim is probably pretty much 0. So I'm going to say that this one is invalid. And then our reasoning why is because they had a stereotype. So saying that all people like to swim is not true. The chance of that happening is very, very low. And looking at part B, it says a pound of Julia's Special Blend coffee costs more than $22.75 per pound. John didn't buy Julia's Special Blend when he purchased coffee. Therefore, John didn't spend more than $22.75. So again, you can pause the video, read through it, and see if you find anything that doesn't seem reasonable, and then explain why that doesn't seem reasonable. So going through this one, the first sentence, it said a pound of Julia's Special Blend coffee costs more than $22.75, so that would be okay. Then it said John didn't buy Julia's Special Blend when he purchased the coffee. Okay, that's reasonable. And then last sentence, it says therefore John didn't spend more than $22.75 per pound. And that's where it kind of goes wrong. Just because you don't buy this Special Blend coffee doesn't mean that you couldn't spend more than $22.75. So we're going to say that this is invalid. And then our reasoning behind this is that other coffee brands could cost more than $22.75. So we don't have to buy the Special Blend to spend more than $22.75. So moving on from there now, what we're going to look at are identifying errors in proofs. So there's going to be 3 main types of errors that we're going to look at. We're going to have an example kind of showcasing each one of those errors. So the first one, we got Liz. It says Liz claims she has proved that -5 equals 5. So that right there is already a red flag. You know that's not true. So you know that there's going to be some type of error in the proof. So the first thing she said is, I assumed that -5 equals 5. Now, right there I can already stop. I know that isn't true. She's starting with something right off the bat that is false. So everything after that is also going to be false, regardless of what she's trying to prove. So what we call this type is an invalid initial assumption. So it started with something invalid and then tried to prove something based off of that. And to answer the question, where is the error in Liz's proof? That error is right in the first line. That right there is an invalid initial assumption. Okay, so that's the first type of error. We're going to see a second type of error in part B here. So it says, Joel decides to prove that the sum of 4 consecutive integers is evenly divisible by the number of integers that is in the set. And there's going to be 4 integers, so we're going to be dividing by 4. And the word evenly divisible, all that means is that when you divide by 4, there's not going to be a decimal. It divides evenly into whatever number is in the numerator. So let's look at Joel's solution here and walk through and try to find the error that he made. So it said, let n represent any integer. And then he said, let n plus 1. Remember, if you have one more, that's just the next number. And then he went n plus 2. So that would be the next number after that, and then n plus 3 represent the sum of 4 consecutive integers. Consecutive meant one right after the other. That's why it's got the 1 plus the 2 plus the 3. Then what he did was he took all of those, he added them, and then divided by 4. That's what we said we were going to divide by at the start. So that represents the sum of the 4 consecutive integers divided by the number of integers. Again, dividing by 4. Then what he did was he said, I can simplify this. He took the n's, so one n plus another n plus another n plus another n, that's 4 n's. And then 1 plus a 2 plus a 3 is a 6, and that's all being divided by 4, so divide by 4. He simplified that and he got this right here. So his final conclusion, he said, since 4n can be divided by 4, this proves that the sum of the 4 consecutive integers is evenly divisible by the number of terms. So he went 4n, divide that by 4, that would just give you out n, and then he put the 6 right there. So we're asked the question, where is the error in Joel's proof? So the error is actually going to occur in this line right here. So if you want to pause the video and try to find the error that he makes, you can do that. So the error is actually this right here. That's 6. Because if you had 4n plus 6 being divided by 4, remember we had this type of question in a previous video where we said you need to break it up. 4n divided by 4 plus 6 divided by 4. So each of them have to get divided by that 4. You can't just pick one or the other. Both of them get divided by 4. So in the first one, the 4's would cancel out and you just get n. But in that second one there, 6 divided by 4 does not divide evenly. You can reduce the fraction, but you're not going to divide evenly into it. So that right there tells us that it's not evenly divisible. So the type of error that we actually made in this one is called a math error. He did not do this division here correctly, so we ended up getting a math error. So that's our second type of error. The next type of error, we're going to look at page 42, and we're going to look at question number 3. And you can look to your textbook, or I just have it right here. So in that question, it says, Mickey says he can prove that 2 equals 0. So again, this is a big red flag. So because he's saying something like that, I know there's definitely going to be some type of error somewhere in the proof. So it says, here's the proof. So he starts by saying, let A and B be equal to 1. So if A and B are both equal to 1, you could say that 1 equals 1. So that's how they start out. And then A is 1 and B is 1. So that's how this begins off. And then what they did was they squared both sides. And on this side, it's describing what he's doing. So squared both sides. Then they subtracted a b squared from both sides and moved that over. So we now have a squared minus b squared equals 0. Then this is a difference of squares, so you can factor it. And when you factor it, you're going to get this. Again, equals 0 still on this side. Then what he did was he took this and he divided that by a minus b. So divided by a minus b. And if we do that on this side, you have to do it on this side. So divide by a minus b. Now this a minus b and this a minus b are going to cancel. So you just get a plus b. So there's a plus b. On this side, 0 divided by anything just gives us 0. And then a and b were both 1s, like we said at the start. So this turns into a 1, and this turns into a 1. And 1 plus 1 is 2. So I now have 2 equals 0. And again, we know that's a red flag, so there's definitely an error somewhere in there. So if you want to pause the video and try to walk through those steps and see where you think there might be an error, you can do that. So if you didn't find the error in this one, don't feel bad because we haven't seen this type yet, and this one is kind of difficult to do. So the error in this one is actually called dividing by 0. And oftentimes when you can't really find where the error is, most likely it's because they're dividing by 0. So I'll show you how he divided by 0. If we take this first statement, a equals b, so I'm just going to write that here. Then what I'll do is I'll subtract a b from both sides. So these b's will cancel. And on this side I'll have a minus b. And on that side we just had 0. So I know that a minus b equals 0. And recall that we can't divide by 0. So if you ever had like 5 divide by 0, that would give you out an error. So you can never divide by 0. So that means I can't divide by a minus b. But right here, they are dividing by a minus b. And that is 0. So at that point right there, they're actually dividing by 0, which is the error. So again, just to recap, whenever you see something that you know is definitely not true, and it's kind of hard to find the error, most likely what it is they're dividing by 0. Just take the initial kind of statement, reorder it, change it into some other type of expression, and then usually you're going to see that somewhere, and they're going to be dividing by it. One other really important note with these questions, guys, make sure you're very, very precise where you're saying the errors are occurring. If you just say that the error occurred in this line and you don't specifically kind of circle the error, you're not going to get full marks on a quiz or a test. So like in this one up here, we were really specific. We circled this and we explained that it should have been a 3/2. So you want to be really, really precise whenever you are explaining errors in proofs. So be very precise when describing or identifying errors to get full marks. So again, that was our last type of error. First one was an invalid initial assumption. Second one was a math error. And then our third one was dividing by 0. So next what we're going to look at is called circular reasoning. So with circular reasoning, it says it is an argument that is incorrect because it makes use of the conclusion to be proved. So you can't try to use the thing that you're trying to prove in a proof. That would be backwards. So if you had something like x is true because of y, and then you said y is true because of x, you're kind of running around in a circle. So you can't do that, and that's why it's called circular reasoning. Another example of this would be this right here. So Sally never lies. This is true since Sally told us so, and Sally told us so. We know this is true because Sally never lies. So it kind of keeps going around and around and around, and you want to avoid that kind of circular reasoning. We got another example here in this illustration, and it deals with gravity. So if you want to read that, you can read that there. Just pause the video. I'm just going to reiterate that kind of illustration with a kind of circular diagram. As a circular diagram, it makes a little bit more sense. So it says mass creates gravity because dense planets have more gravity. Or you could say dense planets have more gravity because mass creates gravity. So it just kind of keeps going around and around in a circle, and you want to avoid doing things like that. So now that we're done circular reasoning, that brings us to this right here, which I'm sure lots of you guys have seen these before. Either you've worked on them or you've seen them on the back of a newspaper somewhere. So this is called a Sudoku puzzle. And what you want to do is you want to fill the columns with the digits 1 through 9. And every row should also have the digits 1 through 9. And as well, every box here should have the digits 1 through 9. So you want to fill in the digits, only placing in a digit when you for sure know that it can fit in that spot. So we're going to go through a couple of these and find a few answers. So we are going to find this one right here, and then after we're also going to find that one right there. So to find this one, what we need to do is we need to check and see what numbers can actually fit in. So if I tried to do a 1 can't go there because I already have a 1 in this column. There's a 1 right there, so it can't be a 1. If I tried to put in a 2, there's already a 2 right there in this row, so it can't be 2. For a 3, okay, there's no 3 in this row, or in this column, or in this box. So it could be a 3, so I'm just going to write a little 3 and keep it in there for now. For a 4, it can't be a 4 because there's a 4 right there in the row. There's also a 4 already in this square. Can't be a 5 because there's one right there. Can't be a 6 because there's one right there in the row. Can't be a 7 because there's a 7 there. Can't be an 8 because there's an 8 there. And it can't be a 9 because there's a 9 right there in that column. So the only option we actually have is a 3. So I'm going to put a big 3 in that box there now. So if you want to now pause the video and try to figure out this one, it's quite a bit easier, but you can pause the video and try to figure out that one. Now this one here is a little easier just because the numbers that we already have in this row, we have every single digit except for 1. So the only digit that is not in here, we got a 1, 2, 3, 4, 5, 6, 7, 8, but there is no 9 in this row. So this one has to be a 9. So in our textbook questions, you're going to have one practice Sudoku to work on. So these are our textbook questions, page 42 and page 56. This is going to be the Sudoku one, and it's only a 6 by 6. This was 9 boxes by 9 boxes. The one you get is only 6 by 6, so it's quite a bit smaller.